Welcome back to the gmShiny video tutorials. In this video, we are going to talk about the basics in the linear models page. Like the rest of these videos, we are using the Plethodon species dataset that was loaded on the data input page. And after a few steps on the data prep page, we can jump straight to this linear models page if we'd like. This page, compared to the rest of this Shiny app, is probably the least representative of the possible flexibility geomorph has to offer. There are many more things you can do with these linear models in geomorph in R than is available currently in this gmShiny app. However, this page will give you a glimpse into what is possible and hopefully give you some exciting results that would spur you forward. So the first tab in this linear models page is called Model Design. This is required for these analyses and the subsequent tab based on allometry, but the model comparison and trajectory analyses tabs can be done independent of this model design. Anyways, this first part of the main panel that you see is a text that will tell you exactly what you have defined as your model. And it'll change based on what you choose over in the settings panel. Right here, we've got an option to define the independent variables that you'd like to test with your model. And these are all options that we uploaded on the data input page and selected to move forward, along with the centroid size that was generated during the generalized Procrustes alignment. So we can select several of these variables, and you'll notice that as soon as I pressed more than one variable, another option right below popped up. And what this second option, this trade order option, does is it allows you to drag and drop and redefine the order of your independent variables. And as you're moving these around, the text identifying which model you're testing is changing to match exactly what you've got here. So let us test this model where we've got centered size, discrete example data set A, and the continuous example data set all as part of the model in that order. Checking over here that this is the actual model we wanted to run, we can be happy and choose some other options. Further down in the settings panel, we can specify the analysis type, and we can tack on several other related tests that you might want to do in tandem. So for any data set that you're testing that has several levels or is discrete, you can ask for a pairwise comparison. You can also look at morphological disparity across those groups. And if you select pairwise and this morphological disparity, it'll give you the overall results for disparity and the pairwise results. And for fun, let's just add evolutionary rate groups in there as well. And you can see these things are popping up, but nothing really interesting looks like it's happened yet. And this is because this is one of the pages where you've got to define several settings before actually running anything. And so that is what this big dark blue calculate button is for at the bottom of the settings. Once you're happy with all these options, you can change the number of permutations or the sums of squares. All those things you can press calculate, and we've got a nice weight button up in the top right before our results pop up for us here. The top box here is the overall results. It first pops out the output that you would get if you were using geomorph in R, just to specify what you were calling and some of the elements of this linear model fit. Down to the bottom left, we've got our simple ANOVA table that you can export as a CSV quite nicely. And we've got some information on morphological disparity, the Procrustes group variances, and evolutionary rate. As we indicated, we wanted those tests run on the discrete example data set A in this panel over here. The bottom here shows those same sorts of analyses, but with the pairwise analysis tacked on. Here we've got a pairwise ANOVA table telling us the differences between those different levels within discrete example data A. Same thing for the morphological disparity analysis pairwise and the evolutionary rate analysis done pairwise. So once we define a model and run it, we can move on and look at the allometry associated with that model. For simplicity's sake, I'm going to simplify this model a bit so that we're just looking at shape as a function of centroid size. So I changed all these settings. I'm going to rerun this ANOVA and get the results and move on to the allometry using this specific model tested. And when you get to the allometry tab, that same model has just been copied over to this next tab to make sure you know exactly what you're looking at. And here we've got a plot of the predictor variable defined in the settings panel against PC1 for those fitted values. Here are your options. You can have the regression type be the prediction line or the regression score, and you can change your predictor variable based on the various elements that you've uploaded for your trait data. So let's say we want to, well, that doesn't make too much sense with the model that we're testing, but we'll just keep the predictor variable as the continuous example data set. And like other tabs, we can change the color of the points to match any of the discrete data that we have uploaded. We can do discrete example data A, or we could do B, whatever you need to do to visualize your data appropriately. The model comparison tab is set up similarly to the model design tab, where we have options to include independent variables in each of the models. This first set is for model 1, this second set is for model 2, and you have this option here to add a third model. And this model comparison tab is limited to only comparing 3 separate models. So let's start with defining a fairly complex model for model 1. And again, if we select more than one variable, we can determine the order just by dragging and dropping. And then, okay, let's say this second model is a little bit simpler, and let's add a third model where we're just looking at discrete example B alone. So you'll notice that as I was making all these settings changes on the right, the text over here was mirroring those changes to show us models 1, 2, and 3, just to make sure that everything is crystal clear. And this is another page where we have to set all these settings before hitting calculate. It'll run for a second. And then here we've got the results of that analysis. This is the R output, and this is the cleaner version of that same ANOVA table that you can easily export. The last tab on this page is the trajectory analysis. And this is another one of those tabs that's better demonstrated with a different data set. So I will add on a different clip at the end of this video with a different data set to better exemplify what we can do with trajectory analyses. Now we'll upload a different data set that can be used to show how trajectory analysis can be applied. This data set, a couple data sets, can be found in the gmShiny GitHub repository. If you look in that testing data sets folder, you can have some options to look at the trajectory tab data sets. So let us look at this land_vig, which is short for vignettes, TPS shapefile. And for the trajectory analysis, there are some trait data associated with it. So let's upload that vig_trait CSV, and we'll include both treatment and family, both of which are discrete traits. And take a look, see if that's the way that it should be. It is. And for this particular data set, we actually have a CSV that is associated with the sliders or the semi-landmarks. So we can actually demonstrate how that matrix can be filled in using an upload. Simply just fills in that matrix that, again, we can edit by hand if we'd like, but we don't have to. Let's apply that semi-landmark matrix to make sure it's doing things we think it should. Then we'll run this GPA and jump over to the linear models trajectory analysis tab. All right, so in the settings here, we can select a trajectory group and the trajectory points. These need to be separate choices, and it's again dependent on the discrete trait data that you uploaded in the data input page. You can add on an additional covariate if you'd like. That could be any of those other data sets that you've uploaded. And whatever model you define is going to be explicated up at the top of the main panel, as with the rest of this page. Let's press calculate to see what this shows. And you can see as long as this white circle is spinning, it's still calculating. Okay, so that was a big data set. Here we have the trajectory analysis, PC1 for the fitted values of that model, PC2 for the fitted values, and we've got a big legend here showing which shapes correspond to the group levels, and then the colors corresponding to the points levels. And those colors you can adjust down here. 13, 14, 15, and 17 are the names of those levels of the inputted data. And we've got a big output that shows up in R. You can export those statistics or the plot. Let's try a different data set that shows trajectory analysis as is explained in the help file for this function. So let's look at the other one. This is land.tps. And here we've got trait.csv for this data set, and we can add sex and population as two of the traits that we're interested in. Notice quickly that this prune data sets to match button showed up. However, that's just because the naming of these files requires that we assign new names, and then it'll just number the specimens 1 to however many specimens we have, 54. And then it looks like these data sets are corresponding, and we can go to the GPA, run that GPA, and jump over to our linear models trajectory analysis. Now we've got our trajectory group as sex, trajectory points as population, no other covariates. Let's press calculate on this one. Here's a simpler trajectory model where we've got just a trajectory between one group to another, colored by that other discrete group. And we can switch it up if we'd like. If I select the trait group that was already selected as trajectory points, it'll automatically fix it so that that's not the case. But if you change it up, you've got to hit calculate again. Welcome back to the gmShiny video tutorial. In this video, we'll talk about the extras page. You likely have already found this tab, this tutorials tab, because this is where you'll find the rest of the video tutorials to walk you through the functionalities of this app. But you can also look at some other features. So this news tab will give you information on how the gmShiny app has changed over time. It'll also let you know what the collaborators are currently working on, so what to look forward to, and then it gives you some options to contact the developers. The first link here is what you want to utilize if there are any errors that you notice in the app or any discrepancies that are confusing. Please report those issues using this GitHub issue reporting. If your question is more directed towards geomorph as an R package and not specifically about the app, you can ask that question using the geomorph listserv. You can also, if you have a question that doesn't pertain to an issue within the app or a question related to geomorph, you can contact me, Dr. Erica Bacon, by just writing me an email. The last tab on this extras page gives you information on how to cite the app in geomorph 4.0, and it directs you to the GitHub repository that houses all the source code and relevant files for this app. Thanks for visiting the app, and I hope you have fun.